right, go ahead and take your homework out and turn to page 489. Page 489. You did numbers 1 through 14. Numbers 1 through 14. Last night for homework, we were practicing multiplying a monomial times a polynomial, along with some other math as well there, a little bit more algebra. Excellent. And I used a word to describe multiplying a monomial times every individual thing in the polynomial. And we call this type of multiplication well, we use the distributive property, so we call it distribution. There we go. So we're using distribution to multiply or distribute the 5 to everything in the parentheses on number 1, for instance. And Lana, when you did that, you got?
Negative 30m squared positive 10m.
Good. Negative 30m squared positive 10m. Number 2, Joshua, when you distributed the negative 2, you got?
Negative 14g to the 4th positive 6g squared.
Good. Negative 14g to the 4th positive 6g squared. Number 3, when you distributed the c, Lana?
44c cubed negative 80c squared.
Good. 44c cubed negative 80c squared. Number 4, Joshua. Uh-oh, what happened?
I forgot about the other c.
Ah, so you just had negative 80c.
Yeah.
You multiply the c to the 44c squared, but you forgot to multiply it by the negative 80c.
Yeah.
Ah, make sure everybody's it'd be like not giving Lana candy. I mean, Scott don't deserve any. He's not here, but but Lana, she's here, so she ought to get candy if we're going to be distributing candy. And Lana was in the class and you didn't give her any. She's mad at you now, just so you know. Look at that look of hate on her face now. Just kidding. I don't know that Lana could make a look of hate. All right. Though we might ask her family and they might tell me something different. I don't know. Number 4, Joshua.
27d cubed positive 90d squared.
Good. 27d cubed positive 90d squared. Number 5, Lana, when you distributed the 12p.
132p to the 5th positive 36p cubed.
Good. 132p to the 5th positive 36p cubed. Number 6, Joshua.
2x to the 4th negative 6y.
Not quite sure what you did here. Yeah. Yeah, let's look at this. We've got a negative 6y that we need to multiply by a 2x cubed positive 3x. So when we multiply here, remember the 3 steps to multiplication are?
Sign, number, letters.
So sign,
Negative,
number,
12.
letters.
Y can't go with X.
Right, so you just keep them both.
Oh.
They neither one of them have friends, but
Yeah.
they're both here.
Yx to the 4.
Why would you make this an x to the 4th?
No, because I was looking at the other one.
Oh, no, just right here.
Yx to the 3rd.
But to keep them alphabetical, x cubed y. Does that make sense?
Yeah.
All right. And then we're going to distribute here. So ignore this. We're done with this. Now we're looking here. Sign.
Negative
Number.
18.
Letters.
Yx.
XY.
Oh.
Alphabetical order. So negative 18xy. All right, it's okay. I will train you to do it. Don't you worry. By the time I'm done with you, you'll be automatically alphabetizing everything. People won't refer to you as being OCD. It would be CDO. We want them alphabetical. All right. I'm a little CDO myself, so I can relate. Number 7, Lana, what did you get when you distributed?
80n to the 4th positive 8n squared.
Good. 80. Positive 80, by the way. N to the 4th positive 8n squared. Don't have to have that first positive, though. Number 8, Joshua.
B to the 4th negative w to the 5th.
All right, let's go and take a look at this one as well.
Too.
We've got, I know what he did on this one, negative v squared w, and you're multiplying that by a negative v squared negative w to the 4th. All right, so when you distribute here, sign,
Positive.
number 1, technically, we don't need to worry about it. Now with the letters, the v squared has a friend.
V to the 4th.
The w has no friend, but he still exists.
Oh. W.
Right. You treat it like, because there wasn't a W here, don't worry about him. And then when you came here, you acted like, well, so the V doesn't have friends, so the V doesn't exist. Again, even if he has no friends, he still exists. So now let's do the second distribution. Sign?
Positive.
Number?
1.
1. We won't bother. And letters?
B squared W to the 4th. Oh, right, to the 5th.
There we go. So again, it's just a matter of realizing, okay, even again, no friends, that's okay, V squared still here, W to the 1st, W to the 4th, W to the 5th. Make sense now?
Yeah.
I did the same thing he did.
You did the same thing that he did, where you saw, okay, this gives me a V to the 4th, W doesn't have friends, we don't care about him. V squared doesn't have friends, we don't care about him, but W to the 5th. Careful. Even if there's no friends, they still exist. All right, and then number 9. Let's go back to Joshua for redemption.
Negative 900 C to the 7th D to the 5th. What did I do?
That's a good question. Let's take a look at number 9 here. We got a 5CD squared that we're distributing to a 15C to the 4th D negative 12C squared D squared. Okay. And Joshua, now that we've worked on these two, I'm going to let you walk me through. What do we do?
Okay, the sign is positive. Yeah, I think I can see it. But the sign is positive. It's C to the 5th. Oh, right, forgot the number.
Yeah, don't want to go over sign, number, letter. So sign is positive. Number
is it 75?
75.
Oh, I put 120.
So then they said C to the 5th and
D to the D cubed.
all right.
And
We're
then
done with that, remember.
Yeah, sign is negative. 60 C cubed D to the 4th.
See, I know I
There
had
we
everything
go.
except the 75.
I'm sorry, you got everything
I
except the 75?
Yeah, I had put 125.
Yeah, that would be 5 times 25, not 5 times 15. So maybe trying to go a little too quick. And you're going to think of it on a clock, Lana, 15 minutes, 15 minutes, 15 minutes, that's an hour, 60. Then 15 more minutes is 75 minutes after the hour, if you will. So if that helps you think. I always think in terms of clocks when it comes to 15s. All right, number 10, number 11, you're just writing either like or unlike for number 10 class.
Unlike.
Number 11,
Unlike.
unlike.
Is
Yeah, 1, there's only...
no, I didn't even see that.
All right, well, the whole point of the problem was to make sure you would see that, so be careful, careful. All right, number 12, combining like terms, and what did you get? Josh, we'll start with you.
Negative 7a squared positive 5a cubed.
Good. Now, I want to throw this out there real quick. This is something I will emphasize more when we get to Algebra 1. But as you look at these two terms, one of these is bigger than the other as far as the letter goes. You see how this has 3 A's in it? This only has 2. This is a bigger power. You would say this is a more powerful term, right? If you want to think in those terms. This is a less powerful term. And so there's something in algebra called descending order of power. Or we generally just say descending order, where when you write your answer, you want the most powerful term written first, 5a cubed, and the less powerful term, negative 7a squared, written later. Does that make sense? Not something we've emphasized a lot, but let me give you a problem real quick, just not in your book, but to see if we can kind of get the idea. So if I had a 6m plus a 9m to the 4th minus an 8m squared plus 2. What's the most powerful term up here, Lana?
The 9m to the 4th.
The 9m to the 4th has the biggest power. We could say it's the most powerful term. What's the next most powerful term, Joshua?
Negative 8m squared.
Good. What's the next most powerful term, Lana?
6m.
Positive 6m. And then the least powerful term, it actually doesn't have a power at all. It's powerless. Class is, of course, the positive 2. This is something we're going to work on in Algebra 1 Pre-algebra, I don't know that I care too much, but I thought I'd at least mention it, is having this descending order. If you wanted to start working on noticing that, I'll point it out periodically throughout the rest of the school year, but I thought I'd throw it out there for you. If you could wrap your mind around it, great. If not, I'm not going to stress over it in pre-algebra, though I will in algebra 1. Number 13, Lana, what was your answer?
8x cubed positive 1x squared.
Good, 8x cubed positive 1x squared. And just by happenstance, you had that one in descending order already, didn't you?
Oh, I put it in the other.
The ascending order where it got bigger? Okay. Let's see.
Wrong?
It's not wrong, no. There's somewhere we're going to go with this in Algebra 1. We're really not going to go far enough in pre-algebra for it to matter, to be quite honest. That's why I'm not emphasizing it. In Algebra 1, we're going to use, I erased it. We're going to use polynomials so often, and if they're in descending order, everything works great. If they're not, it gets messy. So you're going to get in the habit next year of putting them in descending order. Really isn't going to make that much of a difference here in 8th grade. Number 14. What did you have, Joshua?
15c squared d.
Careful. Now, 2 of those terms are like to each other. Which 2 are like terms?
12c squared and negative 5c squared.
Right, so those will combine together to get
7c squared.
But the other term doesn't have any friends, but he still exists.
Positive 8c squared d.
Right, and we're going to actually leave this. You can't mush them together because they're not like. We just leave our answer just like that. Make sense?
What about the 2c squared?
Well, but they're not like to each other. It's like saying a 7m and a 7m cubed. Well, they both have m's. Well, yeah, but they're still not like. Or a 7m cubed n and a 7m cubed x. They're not like because the letters aren't exactly the same.
What you were doing
Earlier, and that's the reason why they keep slipping these addition problems into the homework while you're doing multiplication to make sure you can tell the difference. Because what we're going to do today, you've got to be able to bounce back and forth between the 2 processes. One moment you're multiplying, later in the same problem you're adding. And so that's the reason for it, just to keep you on your toes, shall we say. I'll give you a little bit more practice with this here in just a moment. But for now, let's go ahead and slide down to the bottom of the page. I want you to do numbers 33 to 40. We're practicing with what we see on the side poster there with adding signed numbers. So if you need to refer to the poster, you may. Hopefully you don't need to refer to it too much. But adding signed numbers 33 through 40, they're at the bottom of page 489. So remember, Scott, if the signs are the same, add and keep the sign. And if the signs are different, subtract and keep the sign of the greater absolute value. Of course, also keep in mind, we never really subtract, we add the inverse. So if it says to subtract, change that to an addition problem, and then right back to those rules, which are inconveniently not on your YouTube screen. Guess if I were a good teacher, I would move the poster off the sidewall where the camera could see it. But I'm not that good a teacher, am I, Joshua? I'm just a lazy teacher. There we go. That's the poster in question. Right there. Now my YouTube audience knows what poster we're talking about. All right, let's see how we did on these. Number 33, Joshua? Negative 5. Signs are different, so subtract to get 5. Keep the negative because that was the greater. Number 34, Lana?
0.
They're inverses. They cancel. To get 0. Number 35, Josh?
7.
7. Subtract, keep the sign of the greater. Number 8, Lana? Number 36, Lana?
-8.
Negative 8. Oops. I think I said the answer there by mistake. Negative 8 is correct. Add nothing, no change. Number 37, here we had to add the inverse, Josh.
Negative 6.
Negative 6. You change it to plus a positive 7, which gives you the negative 6. Number 38, Lana.
Negative 18.
Good. You add the inverse, make it negative 8 plus negative 10 to get negative 18. Number 39, Joshua.
9.
Positive 9. You're going to change it to adding a negative 3, which is, of course, gives you 9. And then number 40, Lana.
Positive 10.
Positive 10. Add the inverse to get to 10. Good to go on all of those? Just a quick refresher on signed numbers. Again, we're going to see quite a bit of signed numbers and adding signed numbers like we've been adding signed terms. Jump up to the top above the homework now, 52 to 59. Same type of thing. 52 to 59 just above the homework section. And number 52, Josh.
Negative 4.
Negative 4, 53.
Negative 7.
Negative 7, 54.
3.
3, next one.
0.
0, good.
Negative 3.
Negative 3.
Negative 1.
Negative 1.
5.
5 and
Positive 7.
positive 7. Perfect on all of those. All right, quick classwork for you. We have a monomial, and because it's up against parentheses, that means we want to multiply the monomial times the polynomial. Once you do that in your seats, then here, notice there's no multiplication. It's just combining like terms. Work both of these classwork problems there at your seats if you would. Need a little bit more practice since we had a little bit of a struggle on that homework. All right, let's go and take a look at these together. Looking at the first one here, multiplication. 3 steps to multiplication. Class, they are?
Sign, number, letter.
Sign, number, letter. How many times do I have to sign, number, letter to fully distribute the negative 3x squared y, Joshua?
3. 1, 2, 3. Oh, 4.
4 terms. I'm going to have to sign number letter 4 different times. Joshua, I want you to take the first sign number letter.
Negative 15 x to the 5th, y to the 5th.
Y to the 5th.
Wait, y to the, no, just y.
Just Y. Lana, I want you to take the second sign number letter.
Positive 21 x squared y to the 5th.
There we go. Joshua, take the next sign number letter.
Negative 6 x to the 6th. Wait.
Why don't you look at the chalkboard instead of your paper?
Negative 6 x to the 3rd, x cubed, yz.
Good. And then the final sign number letter, Lana.
Positive 3 x to the 6th y cubed.
There we go. Try to get a feel for each individual multiplication is separate. Once you focus on one term at a time in the distribution. Don't try to run them together, one term at a time. Does that make sense? Let's look at this next problem. All of them have a squares in them, but they're not all like terms to each other because letters have to be exactly the same. Is there a term like to negative 3a squared b? Joshua?
No.
No. He has no friends, but he doesn't cease to exist. So I could keep negative 3a squared b. Is there something like to the positive 7a squared c, Lana?
Yes.
What else?
The positive 4a squared c.
All right, so those are like, those can combine.
Positive 11a squared c.
And then anything like to the negative 8a squared, Joshua?
Yeah. The negative 2a squared.
So we combine them to get,
Negative 10a squared.
there we go, and there's our answer. Negative 3a squared b, positive 11a squared c, negative 10a squared. Questions on these two classwork problems? Did this help to clear up some of the struggles we had in the homework? I feel like we're getting the hang of it now. Excellent. Well, yesterday and in the homework, in fact, what we just did a moment ago was taking a monomial and multiplying it by a polynomial. But you can multiply polynomials together as well. So if you'll turn in your textbooks to page 486, we'll see that we can multiply two polynomials together. And there's a couple names for this process by which we multiply polynomials together. We can call it double distribution, or it's sometimes called FOIL. Double distribution, or what we call FOIL. Now, they don't see that double distribution word, but go ahead and write that at the bottom of page 486, if you would, please. Double distribution. I want to show you how this works. We'll take the binomial x plus 3, and we'll multiply it by the binomial x negative 2. I want you to observe that there are two different terms in the first binomial, right? There's the x and there's the 3. But for a moment, isolate in your mind, only focus on the x. We're going to distribute the x as if it were a monomial times a polynomial, which is what we just did. So ignoring the existence of the 3, what would I get if I distributed the x? Lana?
X squared. And then, negative 2x.
Good. X squared and negative 2x. Then you've distributed the x as far as you can, right? There's no more distribution left. So now ignore the existence of the x, only distribute the 3, Joshua.
Positive 3x, negative 6.
Good. As we distribute, we get a 3x, negative 6. And that's double distribution. However, oftentimes when you double distribute, you may create a couple of terms that are like to each other. Here we've got the negative 2x is like to the positive 3x, so those can combine together, class, to give me
Just 1x.
positive 1x.
Oh, wait.
We've got an x squared, positive 1x, negative 6. And there's our answer. This is sometimes referred to as FOIL. FOIL stands for first, outer, inner, last. And it's used specifically for just binomials. We will talk about later bigger polynomials you could multiply, but FOIL is specifically used just for binomials. Notice the first refers to the first term in each binomial. They each had an x to start out. Outer refers to the two terms that are the outermost in the binomials. They're toward the outsides. Inner refers to the terms that are all the way to the inside, mushed up against each other. And then last refers to, if these are the first, then these would be the last, wouldn't they? And notice it's exactly what we just did in double distribution. We'll distribute here, that's your first, outer, inner, last. It's another name for a special double distribution of binomials. But notice here how, again, the outer and inner are like terms. The x squared has no friends, the -6 has no friends, but the outer and inner products are like to each other. They combine to give us the x. And we see the same thing here. We can think FOIL or we can think double distribution. It really doesn't matter which way we approach it. Look, for instance, at the yellow box, page 487. We've got a y minus 3 being multiplied by a y positive 5. As we multiply here, we can either think double distribution or FOIL. For practice sake, let's practice what FOIL stands for, class. First, outer, inner, last. Again, first, outer, inner, last. If that helps you, great. If not, we can think double distribution. But let's give it a try. My first would be the y's. Well, in double distribution, that's what I multiply first anyway, are the two y's together. So when I multiply the y's, class, I get
Y squared.
when I multiply the outer, that's the outermost terms. They multiply sign number letter to give me
Positive 2.
positive 5y.
Yeah.
Then I'm going to multiply the innermost terms together. Well, sign number letter I get
Negative
3y. And then finally I've got to multiply the last in each of the binomials. That's these two. Sign number, don't worry about letter,
negative 15.
-15. And then finally, the outer product, the 5y, and the inner product, the negative 3y, can combine together to give us positive 2y. We're just combining like terms. Notice we're multiplying, then we're adding. Much like we would have done if we were multiplying a 2-digit number like 32 times another 2-digit number like 21. We start by multiplying the 1 to get, class,
2. Well, 32.
32, yeah.
and of course we shift a little bit here because of place value. Then we multiply the 2.
4,
4,
6.
6.
And then we have to add. Well, there's really nothing to add to the 2, but the 3 and the 4, like an outer inner, could add together to get 7, and the 6 has no friends, and we would keep that. It's not terribly different, but imagine 32 times 21. Distribute the 3,
6,
3.
3.
distribute the 2,
4.
and line it up with the 3,
1, 2.
2, and when you add 6, 7, 2, same answer.
Oh.
Yeah, it's just a different way of approaching it. Now, I will say, the reason you never learned that way of multiplying is because if there was any carrying involved, you're done. Okay? Those numbers were strategically picked because there'd be no carrying, no double digits, anything. But technically, the idea shows how it works. But it's just a double distribution. Take the first term, distribute it. Take the second term, distribute it. And your outer inner will end up giving you, most of the time, like terms that can combine. Turn the page to page 488. Page 488. Let's take a look at number 13, and let's do this together. You can do it right there in your textbooks. We've got an a positive 2 being multiplied by an a positive 1. For starters, we're only going to focus on which of these two terms, class?
The A.
The A. Lock in on the A. Distribute the A, and Joshua, tell me what we get.
A squared. Oh, positive 2.
Oh, I said lock in on the A, distribute the A.
1A?
1A. Easy enough, right?
Oh, okay.
So we just distribute the A. In other words, we do first, then we do outer. Make sense? Now, Lana, we're done with the a. We done multiplied it. Just like in my previous example, once you multiply the ones place all the way through, you shift over, put a 0, and you multiply the tens place. Well, we're just ready to move on to our next term. Now we're going to distribute the 2. We take care of our inner.
So positive 2a.
And then our last.
Positive 2.
Positive 2. And again, that outer inner generally give you, especially when you're working with similar binomials, they may often give you like terms that can combine. The a squared has no friends. The 2 has no friends. But the 1a and 2a combine, class, to give me
Positive 3a.
positive 3a. And there's our answer. Starting to get a little bit of a feel for this? Let's do a few more together, though, before I turn you loose. Ooh, this one has 2 letters in it. I've got both A's and B's, okay? But still, in the first set of parentheses, Lana, we're going to start by locking in on the and distributing it to the other binomial. You never would multiply it by something in its own parenthesis. You're multiplying it by what's in the other parenthesis. So, Lana, what do we get when we distribute the A to the other binomial?
A squared. Positive AB.
Good. What, you're like, oh, AB, what do I do? Yeah, AB, that's it. All right, then we're done with the A, right, Joshua? So now we move on to the B.
The B.
The B, the only other thing that's
I was
there.
just looking.
The B, and then we're going to multiply the B all the way through, and that's where we're going to do our inner and last. What do we get when we multiply to get the inner?
Positive BA.
But we put them in alphabetical order and say
Well, AB.
AB, and then
Positive B squared.
positive B squared. And be very careful. What do I get when I add AB plus another AB?
AB squared.
Ooh, I was afraid someone would say that.
No.
When I add a 1AB and a 1AB, I get a 2AB.
Yeah.
Remember, just add the numbers, don't add the exponents, because we're not multiplying anymore, we're simply adding our terms together. We have an AB, we have another AB, that's a 2AB. Let's do this next one together, number 15. We've got a C negative 5 and a C negative 6. Josh will start by distributing the
C.
In other words, do your first and your outer.
C squared.
There's your first, now your outer.
Yeah. 6C.
Careful, sign number letter.
Oh, negative 6C.
Right, negative 6C. All right, Lana, now pick it up with the negative 5.
So it would be negative 5C. Negative 30.
Sign. I'm multiplying a negative 5 by a negative 6, so
Positive 30.
positive 30, right? Those signs can be tricky if you're not careful. And again, the outer, inner are like terms to each other and can be combined to anyone.
Negative 11C.
So negative 11C, good. So C squared, negative 11C, positive 30. Starting to catch on?
Yeah.
All right, still not ready to turn you loose though. Let's look at number 16. Here they set up a table for us with the outer, first, outer, inner, last. Again, you're still kind of distributing, but they want you to break it down into segmented boxes. And to see if maybe a slightly different look helps it to all come together for us. So number 16, the first, Joshua.
G squared.
The outer, Lana.
Negative 6G.
Negative 6G. The inner, Joshua.
Negative 4G.
Negative 4G. And be careful, Lana, on the last.
Positive 24.
Positive 24. You got it that time. We're going to let it get you. Good. Now, they want the combined form, meaning anything that's like combines. But class, of the first, outer, inner, last, the only ones that ever come out like to each other are the
Inner.
and the outer, right? The outer and inner. So let's combine those. What's our combined answer, Joshua?
Positive 10G.
Well, we first of all want to start with the G squared, right? He's not gone. Just because he has no friends doesn't mean he's gone. We're going to start with the G squared.
Yeah.
Then we're going to combine the negative 6G, negative 4G.
Positive 4G. Positive 10G.
Careful. If I take $6 and then I take 4 more, is that the same as me giving you 10? That's the same as me taking 10, right? The signs are the same. Add and keep the sign. So not positive 10G, negative 10G. And then, of course, we keep our last, which is the
24.
positive 24. So G squared, negative 10G, positive 24. Starting to catch on? All right, let's do another one on the table here. Our first, and this time let's start with Lana.
X squared.
Good. Outer, Joshua.
Negative 132.
That's your last,
Oh.
would be negative 132.
Uh,
But the outer, the two on the
Negative
outside.
11x.
Good. Negative 11x, then come back to the inner, Lana.
Positive 12.
Positive 12x, and Joshua already gave us our last, which was the negative 132. Lana, let's combine the like terms that combine the outer and inner, and what do we get?
Negative 132. Wait, what?
So far, Lana, we have an x squared, we have a negative 11x, we have a positive 12x, and we have a negative 132. But the outer and inner can combine. So what's our simplified answer? X squared,
Yeah.
positive 1x,
Positive 1x.
negative 132. So you're right, we will combine to get a positive 1x, but don't forget about the other pieces that still exist. So our full answer, x squared positive 1x negative 132. Does that make sense? The whole thing's the answer. We're only combining outer and inner, but don't lose the first and the last. They're still there. They just don't have friends.
Oh, so then the last was negative 1.
Right, yeah, that's what Joshua would say. The last is negative 132, and then we just had to combine all of that in the final answer. Tackle number 18 at your seats. See if you can figure the whole box yourself. The first, the outer, the inner, the last, and then combine where you can, leaving only your simplified answer. All right, Lana's got it. And, all right, let's go. Josh, let's see how far you got. What'd you get for your first? 2k squared, your outer?
Yeah, that's
What are your outermost terms? A 2k and a 3, right?
Yeah.
2k at the very beginning and a 3 all the way at the end, multiplying.
6k,
6k. Now come to the middle two terms that are right next to each other.
3k,
3k, and then your last.
5k.
Okay, your last, Joshua, would be the last term in one binomial and the last term in the other. You're multiplying them. 3 times 3 is not 6.
9.
9.
Oh, I keep
Yeah, 3 times 3 is, has been, and always will be 9. So we're multiplying. Right, so it's all multiplication on this step. So the first, the outer, the inner, the last, that's all multiply. Once the multiply is done, then we'll go ahead and do a little bit of addition at the very end. Lana, what was your final answer?
2k squared positive 9k positive 9.
Good, 2k squared positive 9k positive 9 should have been the final answer. Joshua, do you see where she got that? All right, do 19, 20, and 21. Just do those three, 19, 20, and 21. I think if you'd rather, instead of breaking it into F, O, I, and L, if you'd rather just draw some arrows and double distribute the way I first showed, just distribute this one, distribute that one, figure it out. You'd rather just take that approach, that's perfectly fine. You don't have to break it into F, O, I, and L. Technically, it's the same thing, but just a different way of thinking of it. Good for your brain. Helps your brain get better. That's good. It's good to have a good brain, isn't it? You're like, must be nice. I just pick them up. Joshua's just about finished. All right, Josh, we'll start with you. Did you do the FOIL, the FOIL thing, or did you just do the double distribution thing?
I did the FOIL.
The FOIL thing. All right, so let's think FOIL. What did you get when you multiplied the first?
X squared.
The outer?
Positive 3x.
The inner?
Negative 2x.
And the last?
Positive 1.
Ooh, you're multiplying.
Oh,
Sign number.
negative 6.
There we go. Again, it's not sign number letter, it's only sign number because there aren't any letters. Once you've done that, by the way, if you double distributed, you'd get the exact same thing, right? You're just not thinking FOIL, but double distribution would give you the exact same thing. At the very end, we're just going to combine our like terms here, Joshua, and we'll get
X squared positive 1x negative 6.
There we go. Lana, did you do double distribution or FOIL?
FOIL.
You did FOIL as well. All right, so FOIL. Let's see what we got first.
Z squared
Outer,
positive 6x.
well, Z. Inner,
Oh, I was stuck on the last one.
it's okay. Inner,
Negative 3z,
and last.
negative 18.
All right, then you combined the outer and inner together for a final answer.
Z squared positive 3z, negative 18.
There we go. Z squared positive 3Z negative 18. Joshua, good to go?
Yeah, I changed it. I just gotta keep remembering
To multiply on the
multiply
last.
it. Yeah.
Right, so your brain's like adding the last together instead of multiplying the last. And that's why we're doing small numbers of these. We're doing just a few of them, make sure we work out the mental bugs so by the time we're done, you're in a groove. All right, let's take this last one in class. I want to go and double distribute it just for sake of the video here. So let's start by distributing the t. Forget thinking through FOIL, just distribute the t, Josh.
T squared. Negative 2t.
All right, then distribute the 10, Lana.
Positive 10t, and then, do you subtract these?
You're multiplying, you're distributing. Distribute the 10.
Negative 20.
There we go, and now at the end, let's combine these terms together, Joshua, to get,
Positive 8t.
well, that's in the middle, but then we also still have the,
t squared
and the,
positive 18 negative 20.
there we go. I do think the idea of distribution may make it easier. We're just multiplying. That may make it easier to avoid that mistake. So maybe give that a try on a couple of these. Let's go ahead and now have you do 23, 25, 27, 29. 23, 25, 27, and 29. Doing some odd problems now. Joshua's like, they're all odd, Mr. Yasky. Not that kind of odd, Joshua. Odd number. I'm sorry if you're looking crooked at your computer screen there, Scott. I just now noticed my camera is crooked. There, is that better? It's because I wanted to show you my signed number poster. Shouldn't have done it. Messed everything up. If you try the double distribution way and decide, I think I like FOIL better, that's fine, go back to FOIL. And you kind of pick which mental approach you want to take. Whichever way is easier for you to stay focused and do the right thing, you do that. Pencils down, even if you're not finished. Let's go ahead and take a look at these together. On this first one, if I double distribute, I'm distributing the y, I should get y squared negative 2y. Then I'm going to distribute the 2. I should get positive 2y, negative 4. But these are inverses. Negative 2y, positive 2y. Thoughts, class?
You just cancel them.
So my answer is just
Y squared minus 4.
y squared minus 4. Great. On the next one, I'm going to double distribute the p. P times p,
P squared.
p times 4,
4p.
4p.
I mean 4p.
Then I'm going to distribute the 3. 3 times p,
Positive 3p.
and 3 times 4.
Positive 12.
Then we combine our p's to get.
P squared positive 7p positive 12.
Good. Here we're going to distribute the 2x to the x to get.
2x squared.
Then to the 5.
Positive 10x.
Then distribute the 5 to the x.
Positive 5x.
And 5 to the 5.
Positive 25.
Combine like terms to get.
2x squared
Positive
positive
15x
15x positive 25.
Good. On the next one, distribute the 7s to get.
35x.
Squared. Oops.
Oh.
All right, and then s times s is s squared. All right, then the 7s times the negative 4 sign number letter.
Negative 28x.
Then we're going to distribute the 5 to the 5s
Positive 25x.
and the 5 to the negative 4.
Negative 20.
Combine the negative 28s and the positive 25s.
Negative 3.
Get a negative 3s there in the middle. Of course, we'll still have the 35s
right.
squared and the negative 20. And those should have been our answers. No homework this evening. We'll continue working on this in our next lesson. Have a wonderful rest of your day.